Welcome, Mr. Hyatt here. This is the Chapter 14 AP Environmental Science lecture on the human population and urbanization. Our case study starts looking at the population of the Earth. A population of 2 billion took around 200,000 years to accumulate. Then look at what this should scream to you is exponential growth. So it took us 200,000 years to build a population of 2 billion. Took less than 50 years to reach the second billion, then 25 years to add the third 2 billion. 13 years later, we're over 7.2 billion. If that's not exponential growth, I don't know what is. Most of the world's population lives in cities today. So this question down here at the bottom is going to kind of drive our discussion of this whole chapter. We will focus on our town, but we'll also apply to bigger cities, and we'll also look to smaller towns and see how they could be more sustainable. As you well know, the variables are always a little bit different. So, how many people can the Earth support? What is our carrying capacity? There is some debate about what the carrying capacity actually is, and then what happens afterwards. Do we turn into a Mad Max scenario, or it's a end of the world type of thing, or what does that look like? Excuse me. So the human population grew slowly for most of the human history, but in the last 200 years, we've gone crazy. We definitely have a couple of things that have contributed to that. Number one, the Industrial Revolution came about. Number two, the first Green Revolution came about, which is kind of the Industrial Revolution for agriculture. And then technology like airplanes and cars and things like that, boats. But technology has helped humans migrate and live in almost all of the planet's climate zones and habitats. I mentioned the transportation modes, but also things like air conditioning, things like heat, different technologies along those lines. So since 1960, the growth rate has slowed a little bit, but the population is still growing. Like everything else, the population is even unevenly distributed. In less developed countries, we're growing a lot faster than in more developed countries. And of course, more people are moving towards urban areas. See that estimate right there? By 2050, 2/3 of the world's population will likely live in cities. So we need to think about how we can do that sustainably and how we can do that responsibly. What you're seeing here is our population growth rate as a globe. So often students mix up growth rate with population growth, with population totals. So we need to make sure that we're being very careful about what we're saying and what we're trying to say. Notice that this kind of reinforces what I talked about on the last slide. Here's 1960, where we had this steep drop off. And then gradually our growth rate has declined. So that means we're adding a lower percentage of people to the planet every day. We've looked at the human population clock. We know that we add about 300,000 people to the planet each day. But remember, our growth rate is going to be dependent upon the size of our population. So we might be adding more people today than we were in 1970, but it's a percentage of our population. So the percent change is smaller. So a couple of things that affect population size are going to be, of course, birth, death, immigration, emigration. I know that I mispronounced that. I intentionally mispronounced immigration so that students can understand, basically so you can differentiate, because immigration and emigration sound really similar. So I say immigration to talk about leaving and immigration to talk about coming in. So there are some important vocab words and some important figures that we need to be able to calculate as part of this unit. And the first of those is total fertility rate. Notice that that's the average number of children born to women of childbearing age in a population. So how many kids do the average women in a population have? That's going to be different, and we'll see socioeconomically, whether you're a developed country, whether you're a developing country, that total fertility rate is going to be a really good indicator of whether your population is growing quickly, slowly, or shrinking. Things that affect birth and fertility rates
Are children part of the labor force? And in many countries they are. How expensive is it to raise and educate children? Expensive, particularly here in the United States. In other places, not so much. There are fewer children needed to support seniors. We we don't care for our seniors at home all the time anymore. Yes, seniors are living longer, but they often are in assisted living, and they have better access to health care, so there are doctors that can help care for them, things along those lines. There's more family planning in urban areas because, again, we have better access to health care. You don't have to drive 100 miles to get to birth control. You can drive around the corner to get to CVS and get birth control. Access to education and employment outside the home for women has a huge effect on birth and fertility rates. Average age of marriage, of course, the availability of birth control, of course, all these things I think make sense that they would either drive up or diminish the birth rate and certainly fertility rate, which is, like an average birth rate. Things that affect death rates. This is one of the huge reasons that our population has grown. People are living longer. Things like medicine, things like understanding the food groups and healthy living, sanitation improved. The plague was largely carried by mice and rats that lived in waste, in human waste. So we certainly don't do that as much anymore. There are countries where sanitation is really bad, and in those areas the death rates are higher, life expectancy is lower, and so on. Over the last 100 years we're talking about here, the life expectancy has increased. We've seen a few years in there where we've seen a couple of dips down where our life expectancy actually declined. Certainly climate change is playing into that a little bit. And then infant mortality rates have dropped. So this is another one of those things that we need to be able to calculate along with total fertility rate is infant mortality rate. And that's the number of babies out of 1,000 that die before their first birthday. So they're born, they're successful pregnancies, but they don't make it to their first birthday. Again, we know more, we have better technology, we have better medicine, we have more screenings that happen right at birth so we can catch things sooner, and that has declined. And I think that it makes sense that if these three things happen, on average, we're going to live longer, and that's going to drive our population up. Of course, immigration and emigration affect our population size. If a whole bunch of people are coming in, population gets bigger. If a whole bunch of people are leaving, say you're fleeing a war or you're fleeing, here in your book they talk a lot about environmental refugees. Maybe you're leaving famine or drought or soil erosion. We see some of that in the Middle East. So certainly there are populations that are shrinking. Could be fleeing other types of things. So again, increases the population size, decreases the population size. And again, we can connect that to the growth rate and the I don't know what the opposite of that would be, a negative growth rate or a decline rate. So an age structure diagram is something we're going to spend some time with later in the week and definitely next week. And it's basically a graph that shows what your population looks like. So let's start with the one on the right. So notice that age increases as we go up. Our population is on our x-axis, and females on one side, males on the other. That's kind of the basics of an age structure diagram. If we look at this population, we can see that this population is growing quickly. Look how much bigger the diagram is at the bottom than it is at the top. A whole bunch of babies are being born. Not a lot of old people are still alive. Over here we've got more developed countries where the population is a bit more stable. And we've got a bubble right here. That's very typical, right? So we get a small amount of babies being born. Most of them survive. Maybe there's a baby boomer generation in here somewhere that causes there to be a bubble. But we've got roughly the same amount of old people and babies being born. So the population is more stable, or it's changing less. So our population growth rate would be smaller or negative here. Our population growth rate would be a large positive number here. Aging populations can decline rapidly. We see that in Japan. We see that in some established countries in Europe, Germany, we see a large percentage of the population at 65 or older. Anytime you see that, you know that those people are typically beyond reproductive age. They're not making babies anymore. Sorry about that. The younger folks have to support that increasing population. So I want you to think about that in terms of the Affordable Care Act. We do have this baby boomer generation that's approaching this age of 65. So whether you agree with the decision to allow universal health care and whether you support the Affordable Care Act or not, we were I say we, politicians, scientists, people that study population, they're called demographers. They were looking at our growth curve and they were saying, look, we're going to have this huge amount of people, this huge generation that's going to leave the workforce and is going to be over 65, and we have to do something about it. So let's make sure that they all at least have health care. And so that was one of the logic, the ideas behind the Affordable Care Act.